Okay, so this video here is a triangulation pattern development. It's a rectangle to rectangle transition with a 45-degree twist. As you can see, it's 300 along the one edge of the plan view by 225 the other way. Vertically high in the front elevation, it's also 225 millimeters high. The top, the rectangle on the top, this rectangle here is rotated 45 degrees to the base, and it has a size of 87.5 millimeters by 105.5 millimeters. And this is the joint line here. So if you were going to make that in a workshop on a press brake or a folder or something, you would actually have to have a joint line going from point A out to the base on that side. You will not physically be able to form that up properly in a press in one full piece. I'm just doing the pattern in one full piece because that's how I want it drawn. But you would have to make it in two halves and either butt weld it together or spot weld it together or join it, however you so choose to do it. So that's the outline. I've already redrawn it here. I've started to put my, or have put my true length lines in. You will remember having drawn some of these already, or you may not remember that these lines here, say from 3 to A in the plan view, must be put over the vertical height or the true length height in the front elevation. So what we do is we take that length there. I'm just going to do it with the computer. So it has a length here, that line of 144.54 millimeters. So you would set your compass, your dividers, and I'll just demonstrate that here. So circle here, what they say, 144.54 millimeters. So you can see the circle, and you would only draw a small arc across the baseline like these little lines here, but on this computer or on an Autocad you have to draw a full circle and then trim it back. So that's that circle is drawn in from A3, this A3, which is this intersection point right here. We run our line all the way back to our vertical height line, and that gives us our true length line of A3 when it's laid out properly for a vertical height. So that's those done. I haven't done the joint line. Our length of our joint line is 82.82, and if I draw that in here just to show you, we've got circle here, 82.82, and because I'm doing it on the computer, I have to, in AutoCAD, I'm just going to put a small circle there, and I'm going to trim out from that small circle. So that's how I achieved my points. I'm not going to number it. I can draw my line from that back to the vertical height. So there's our true length line, or true length of the joint line. That's the plan view. The vertical height is there, and that is what we derive for the true length line. If we look at that, it tells us that it's 239.76 millimeters long. In actual fact, it's already on the plan. There it is, exactly the same length, 239.76. Reason being, you might remember, the two outside lines on the front elevation are always true length lines. They're not the true length of the corner ones because they are a different triangle, but they are a true length up through the center. So we can determine, take those two lines directly off the plan, and they are true off the front elevation, and they give us true length. So into the development, we've already talked for 4 minutes. So we'll just put in a baseline here, 225 millimeters long, and this point on this end, if I take the letter out of here and paste it into here, this is point 2 on this end. Oh, sorry, it is point 2, yep. And 3 off the other end, clip that out of there and put that onto this end. I'm not going to be too fancy with my numbers this time. I just want to get on with laying this pattern out and try and keep the time down as much as possible. The 2 is on the left hand end, the 3 is on the right hand end. The reason being that we're trying to lay out the inside of the pattern. If I had the 3 at this end and the 2 at this end, would be drawing the outside of the pattern, and I don't want that. I want an inside view of the pattern. So that's why I'm taking it off there. The very next line we want to put in is A to 3, and then we'll put in A to 2. So because I've taken those lengths and scribed my circles, I can take the dimensions straight off here. So A3 has a length. I need to write this down because I started to do this drawing before and made a fool of myself, as I'm prone to doing. 267.43. And if I click off that and click on A2, it tells me it has a length of 263.22. You can do that on the properties box by looking down here at the length figure. So I have to scribe full circles. You only have to draw small arcs to actually do this drawing. So from A to 3, I draw a circle, which has a which is 267.43, and from A2 I draw a circle at 263.22, and there's my intersection point at the top. So I'm going to draw a line from there up to there and back to there, and that's my first triangle that I'm trying to do. So that triangle there, get rid of that, is that triangle from A to 3, 3 to A, A to 2, and 2 to 3. So that's that laid out there. So we'll take the A off the drawing, copy into here, paste. So there's our 4. Incidentally, that you can see that the A position is offset from the center line ever so slightly. So if we take a distance from 2 up to that line there, you can see down here I've offset it slightly when I've measured it. It's 107.55 millimeters, 107.55. So if we go across to this drawing and we lay in a line from the top, from the apex of that triangle. Have I drawn it from the apex? I have. And we come back to there, and then I measure the distance from there across to here. You can see we've got 107.54. I'm just not quite hitting the button correct. I don't want to spend time on it, so that tells me that I've actually offset it to the correct side. The triangle is more to the A2 side than it is to the A3 side. So we're starting to lay it out right. The next line I want is from A to B, and that distance was 87.5, I believe. There we go, 87.5. So from A to B, and that's on the 3 side. So I'm going to draw a circle from there. So I've got 87.5, and that line there is 3 to B, so I take that and I come down here and I draw a circle. What did I say it was? B to 3, 3B. 3B, so we've got, this is it here. So click on that and we have a length there of 273.97. So going from there, drawing my circle, what did I say, 273.97. There's our intersection point for that line, and back to there, so I can get rid of those 2 lines already, and that is point B. Get rid of this thing sitting on the screen, so take off B, copy that, and into here, placing that on the screen there at B. So that's our point B. Come back out the other side, we want D. The length of D should be, what is it, 100.5 millimeters. So A to D, circle from there, 100.5 millimeters. You can see it right down the bottom of the screen and the command bar, laying it in. And that line there, we want 2D, so we've taken that length down to here, which is 2D. This is 2D here, and the length of 2D is, I'm going to write this down again, got 275.84. So going from 2, drawing a circle, C for circle, and I said 275.82. So there's our intersection point. Draw a line. Do it again. From there and across to there. Get rid of these circles here, no longer required. And that's point D. Get rid of that. Copy D up to here with D. Paste it. It's Control 5. I must remember that, but it doesn't always stick it where I want. Right, so the next line we want is from 2 to 1 and 3 to 4. They are 300 millimeters long. You'll remember from the previous drawing, there's the 300. So we want to scribe 2 lines from that corner, 300 millimeters out one side and exactly the same out the other side. Currently it's just a line. We've got to determine the points, and what we need is from B back to 4 this time. This if we go on this line here, it's this line here, so this is line 4, but we want the line from B because we've already got B on the sheet, as you can see in the top corner there. So we need to go from B and determine where point 4 is. So B4, it's the longest line, so the longest one measures 278.2, writing it down, 278.2. So coming back into here, B, scribing a circle. Circle starts with C, not B. What did I say? 278.2. So there's our point. Going to draw our line from 3 up to 4 and back to B. There we go. So we can get rid of those 2 circles. That's point 4. Go and copy point 4. Trying to do this as quickly as possible, of course. There's our point 4. Paste it. Point 4. Now coming out the other side, we want, we've got D. This circle is actually the radius. The circle is for, the radius is 300 mils, so we need to determine where point number 1 is. So the line is D1 that we're looking for. We take that length, scribe our circle, and here is D1 here. So this line here is D1, and it is 269.99. So just writing that down. So from that point, 269.99. No, I did the wrong thing, like a fool. It's got to go from D, doesn't it? Easy to make a fool of yourself when you're doing these things. 269.99. There's the intersection. Draw a line from 2. This is point 1 here and back to D. So we can now get rid of that circle and that circle. We are going to get rid of this properties box. Dancing all around here on the screen. We want point number 1. We're going to copy that, copy it, lay it in here, paste. So there's point number 1. So from D we want to go to C. It's 87.5 millimeters. So we're going to scribe a circle from there. Circle from that point, 87.5 millimeters, and the line from B to C is actually 100.5. So we're going to scribe a circle from there. That's 100.5. So there's our 2 circles. So now we've got this line. We've got 1 to D. We want to go, we've scribed in circle D, C, that circle is that, this length here is the radius for this here. So what we want to go and fit is from 1 up to C, and that'll determine where we hit this actual circle here. So from 1 to C, Where's one to see? It's the shortest one here. It has a length of 259.15, just writing it down again. So from there we're going to draw a circle, 259.15, and that's our point. So we're going to lay those lines in, across to there, back down to there, get rid of those two circles. We've got our intersection, and out on the other side we are going to do from point 4 through to C, so this line here, so C4, where's C4? We've got, okay, so this here is C4 at this point here, so properties on that tell me that it's 271.15 millimeters. So C4, so going from point 4, circle, what did I say, 271.15, 15, that's right. So drawing that's in, we've got 4 up to C, back to B, get rid of those two circles or arcs. So I can take the C off the drawing. It's going to go into 2 places now because that's the joint line and it meets at 2 points. So C into here, pasting C at that point there and also at that point there because it's the joint line, as I said. What do we need to do now? Right, we need to create these last 2 triangles in here with the baseline. So on one side we're going from 4 to 0, and I'm going to take that dimension directly off the drawing. So from 0 up to 4 gives me a length of 126. Need another piece of paper, 126.64. So I'm going to scribe an arc, what do they say, from 4 to 0. So here's 4, and I'm doing a circle. So circle, and I said it was 126.64. And what we need is that length there, which is the joint line. So going from C back down to 0. And we can take that directly off the drawing here. As I said, I haven't numbered it down the bottom, but that's what it is. There's the C up the top, 0 down the bottom, so we can take it directly off that point there, and it is 239.76. So 239.76, circle, going from there, 239.76, and we can draw our line in to there, back to the top, get rid of that. That length there is actually also the same length that comes out on the other side of the pattern from C on the other side. So we're going to draw a circle again from there. I said it was 239.76. There's our circle, and this time we want the distance from 1 up to 0, and it shows it on the screen at 98.36. You can see that right down in the command box down here, delta Y 98.36. So drawing a circle from 1 up to find 0 is 36. There you go. And line, 19 minutes. Gosh, time flies when you're having fun. Up to that point there. And that's point 0, so we're going to copy that out of there. Copy, laying that into there. There's point 0, out the other side because it's the joint line, and it's exactly the same size out the other side. So there's our pattern. Move it slightly, Leave all that information down into here. Get rid of that. Blow it up to full size. The corner should be 90 degrees, so if we do a dim angle, this angle in here is 90 degrees, as you can see, which tells me that the pattern is correct. We'll do exactly the same on the other side. Dim angle again, repeat dim angle, and there's our 90 degrees. So you can always check your patterns. They should be 90 degrees in the corners if you've drawn them accurately. So that's the layout for our original drawing. Done our pattern, numbered it all correctly. Crucial that you number everything whenever you do a pattern, otherwise you can get awfully confused as to where you're going. And just check it by laying the 90 or measuring the corner on the last two angles. They should be 90 degrees. If they're not 90 degrees, your pattern will be wrong. If they're 89 or something like that, that's not too bad, but you know, if they're 5 degrees out or something, you've got problems and you need to sort out what the problem is. So I'll leave that video there. I don't want to talk any longer about it. It's already 21 minutes, so leave it there. Thank you.